I want to work through this question. Give some details at the beginning about the slope of a secant line. The slope of a secant line can be calculated using this difference quotient formula, f of x plus h minus f of x over h. And we want to calculate the slope of the secant line using the function f of x equals negative 9x squared minus 3x plus 4. So we're going to express that slope of the secant line in terms of x and h. And we'll write our answer here. We do have a few other parts that we'll want to work through, but let's go ahead and work out the slope of the secant line first. So we have our function f of x equals negative 9x squared minus 3x plus 4. And we're going to calculate that slope of the secant line. The slope of the secant line in terms of x and h will be f of x plus h minus f of x over h. So as we calculate this, we'll focus on f of x plus h. That expression is going to be the same as f of x, except for everywhere we see an x, we're going to change it to x plus h. So that will give us negative 9 times x plus h squared minus 3 times x plus h plus 4. But then we're going to subtract f of x, which is our original function. So we're going to subtract, and I'm going to put parentheses to make sure I'm subtracting the whole function. I'm going to subtract negative 9x squared minus 3x plus 4, and all of this is over h. Now we've got some algebra cleanup to do. I'm going to distribute this negative to the 3 terms so I can remove the parentheses. I also want to remove the parentheses here by applying the square. Remove the parentheses here by distributing the negative 3. So this will give negative 9 times x plus h times x plus h. That's applying the square. We're multiplying the base twice. Negative 3x minus 3h, distributing that negative 3. Copying down that plus 4, I'll distribute the negative to get plus 9x squared plus 3x minus 4. And this is all over h. Now I'll focus on multiplying out this x plus h times x plus h. That will be x squared plus xh plus xh plus h squared. And I'll go ahead and do a little bit of canceling here. We have a negative 3x and a positive 3x, a plus 4 and a minus 4 that zero out. And I'll copy down the rest. Negative 3h plus 9x squared all over h. So inside the parentheses, I can combine like terms. The xh and xh combine to be 2xh of x squared plus 2xh plus h squared minus 3h plus 9x squared all over h. I'll distribute the negative 9 so I can remove these parentheses. I have negative 9x squared minus 18xh minus 9h squared minus 3h plus 9x squared over h. And I have some more terms that will cancel. Negative 9x squared and a positive 9x squared cancel. That will give me 18xh minus 9h squared minus 3h over h. And I can reduce this fraction because all of the terms in the numerator have a factor of h, and we have a factor of h in the denominator. So we can cancel to get negative 18x minus 9h minus 3. And this is our difference quotient in terms of, our slope of the secant line in terms of x and h. All right, so let's continue with the other parts of the problem. So we were able to write the slope of the secant line in terms of x and h. We got negative 18x minus 9h minus 3. So for the next part, we want to find the slope of the secant line given h equal 0.5, 0.1, 0.01, and x equal 1. So that is us just substituting these values into the formula that we got for the slope of the secant line. Just a little preview of calculus, you're going to be talking about allowing h to get closer and closer to 0. And so we've listed these h's getting closer to a value of 0. So we'll substitute these values of h and x into the formula we got for the slope of the secant line. It's negative 18 times 1 minus 9 times 0.5 minus 3. Let me bring in my calculator. And we'll substitute that 1 in for x and 0.5 in for h. And we've got negative 25.5 for the first one. For the next one, we'll substitute x equals 1 and h equals 0.1. We have negative 18 times 1 minus 9 times 0.01 minus 3. Let's type that in our calculator. Negative 18 times 1 minus 9 times 0.01 minus 3, and that gives us negative 13.09. And I apologize, I think I wrote 0.01 instead of 0.1. So let's correct that, 0.1. And I also typed negative 10 instead of negative 18. So negative 18 times 1 minus 9 times 0.1 minus 3. And we've got negative 21.9. And finally, we'll let h equal 0.01. We have negative 18 times 1 minus 9 times 0.01 minus 3. And we'll type that in our calculator. Negative 18 times 1 minus 9 times 0.01 minus 3 gives us negative 21.09. So you can see our calculation here is starting to focus in on a certain number, probably negative 21, which is something you'll discuss in calculus. So in our final part, we want to find the equation of a secant line using h equals 0.01 and x equals 1. Now, in order to find the equation of a secant line, we have to know the slope of the secant line, which we just found. So that was negative 21.09. And then we need a point on the line. We have the x-coordinate of the point being 1, and we can calculate the y-coordinate by substituting into our function. So if you'll recall, our function was f of x equals negative 9x squared minus 3x plus 4. So f of 1 will be negative 9 times 1 squared minus 3 times 1 plus 4. So negative 9 minus 3 plus 4. So that will give us negative 12 plus 4, which is 8. So we have the ordered pair 1, 8, that's negative 8. 1, negative 8. And we'll substitute this into our point slope form, y minus y1 equals m times x minus x1. Y minus negative 8 equals our slope, negative 21.09 times x minus 1. That's y plus 8 equals negative 21.09 x plus 21.09. We'll subtract 8 on both sides to give y equals negative 21.09x. And let's type that one in our calculator. We're doing negative 21.09 plus 8 gives us 13.09. And I think I did that backwards. I put the signs wrong, so it was positive 21.09 minus 8, and that's 13.09. So now we have the equation of the secant line at x equals 1 when h is equal to 0.01. On this question, we want to find the slope of the secant line, which is f of x plus h minus f of x over h. This is one form of the secant line, which allows you to have x and h in the equation. We're going to calculate the slope of the secant line using the function f of x equals square root of 4x plus 7. So we're going to use this way of writing the slope of the secant line so that we can have it in terms of both x and h. So let's work this out on the side over here. We have our function, which is square root of 4x plus 7. And we're going to calculate that difference quotient. The slope of the secant line is f of x plus h minus f of x over h. So when I'm simplifying f of x plus h, I'm going to substitute x plus h in for x. This will give square root of 4 times x plus h plus 7. The next part of the difference quotient, I want to subtract f of x. So we're going to subtract our original function of 4x plus 7. And this is all over our h. I'll simplify this a little bit by removing these parentheses using the distributive property. This will give square root of 4x plus 4h plus 7 minus square root of 4x plus 7 over h. And we're going to simplify this by using a strategy of multiplying by the conjugate. Now, the conjugate is going to have the opposite sign of what we have in the numerator. That's square root of 4x plus 4h plus 7 plus square root of 4x plus 7. And we're going to multiply by the same thing in the denominator so that we're multiplying by a form of 1. Now, when we do this multiplication, some nice cancellation happens. Because we're multiplying by the conjugate, we're going to end up, when we multiply our middle two terms together and our outside two terms together, they're going to be the same except for having an opposite sign. So that middle part cancels out. So we can just focus on multiplying the first terms together and the last terms together. So when we multiply the first terms together, we're multiplying this radical by this radical. That's square root of 4x plus 4h plus 7 squared. Because those two radicals are exactly the same, we have two copies of them, which is why I wrote that squared there. And when we multiply the last two terms together, we once again have the exact same radicals. It's going to be minus square root of 4x plus 7 squared. So we have those two copies of the 4x plus 7. In our denominator, we'll have h times square root of 4x plus 4h plus 7 plus square root of 4x plus 7. Now, as I said earlier, when you multiply the outside and the inside together, those terms are going to cancel out in the middle, so I'm not writing them here. Okay, so to simplify this even more, the square root and the square are opposite operations, so they cancel each other out. So this is going to give us 4x plus 4h plus 7 minus 4x plus 7. Now notice I wrote parentheses because this minus sign applies to everything in the radical, so it has to apply to the simplified part as well. Now in the denominator, I'm just going to copy down what I already have. And in the numerator, I can use the distributive property, distributing this minus sign, and we have a positive 4x canceling with a negative 4x, a positive 7 canceling with a negative 7 after we distribute. So this is going to leave us with 4h over square root of 4x plus 4h plus 7 plus square root of 4x plus 7. And you'll have to excuse me, I did leave off this h here. So I have an h, and these h's will cancel each other out. And I have 4 over square root 4x plus 4h plus 7 plus square root of 4x plus 7. So this is the slope of our secant line in terms of x and h. So let's continue on with our next part. We've got the slope of the secant line. Let's go ahead and write down what we found. The slope of the secant line is 4 over square root of 4x plus 4h plus 7 plus square root of 4x plus 7. So in the next part, what we want to do is find the slope of the secant line at x equals 1 and for these different values of h. I'm going to use my calculator to work this out. And there's a note here about rounding to 3 decimal places. So this time we have kind of a complicated expression for the slope of the secant line. So I'm going to use some of the graphing calculator features to make this a little bit better. So I'm going to type in my y equals menu this complicated expression, except for I'm going to substitute a 1 in for the x. So that would mean in my y equals menu, I'll type 4 over, I need parentheses around the denominator, square root, 4 times 1 is 1, plus 7 is 11, so we're going to write 4x plus 11. And then if I substitute a 1 in for this x here, 7 plus 4 is also 11, so this will be plus square root of 11. And let me close parentheses for the denominator. So I substituted a 1 in for here. 4 times 1 is 4, plus 7 is 11. And I'm using an x for that h there. So then I'm going to go to the table. Before we go to the table, let's make sure the table is set up right. I want the independent variable to be in ask mode so that I can tell the calculator what values to plug into it. So let's go to the table, and I would like to use a value. Let's delete these values that are already here. And I'm going to use 0.5, 0.1, and 0.01. And so we have our calculations here for all three of these. We want to round to 3 decimal places. So let's see, that's going to be 0.578, 0.598, and 0.603 if we round those to 3 decimal places. All right, so I was just double checking as I was going through this, and it looks like my calculator, so the first 2 were marked correctly and the last one was marked wrong. So here's what I think is happening. This table is only displaying 4 decimal places, and it's rounding this number for me, which is causing me to round this one when it shouldn't be. So I'm going to go to the calc menu, and we're going to do it, let's go to the graph first. And then in the calc menu, I'm going to use second calc number 1 value, and I'm going to let x be 0.01. And this is going to give me all of the decimal places, so I'm not doing this double rounding, which caused a mistake. So we've got 0.602 instead of 0.603. Now for the last part here, we want to find the equation of the secant line. To find the equation of the secant line, we need to know the slope of the secant line, which we just found, 0.602. So we're finding the equation of the secant line when h is equal to 0.01 and x is equal to 1, which is what we just found here in the previous part. We also need to know a point on the line. So we need an x and a y. So we were given our x equal 1. Let's find the y. F of 1 will be 4 times 1, square root of 4 times 1 plus 7, that's square root of 11. So we'll substitute this into our point slope form. Y minus y1 equals m times x minus x1. That's y minus square root of 11 equals 0.602 times x minus 1. The directions here do say to round to 3 decimal places, so in just a moment I'll use my calculator to simplify that square root of 11. So we'll distribute the 0.602, that's 0.602x minus 0.602. We're going to add square root of 11 and get y equals 0.602x. And let's see. Get 0.602 plus the square root of 11. And to 3 decimal places, that would be 3.919. Let me double check that. I got my signs wrong, so it's negative 0.602 plus square root of 11. And that gives us 2.7145. 2.7 2.715. If we round to 3 decimal places. So we found the slope of the secant line when h is equal to 0.01 at x equals 1. I'm going to take a moment to graph exactly what we're doing here. So in my y equals menu, I'm going to put the original function, which was square root of 4x plus 7. And then I'll also put in my y equals menu 0.602x plus 2.715, which is our slope, our equation of the secant line. And let's adjust the window. I'm going to hit zoom 6 to get to that standard viewing window. And what you see here, the graph in blue, that's our graph of the square root of 4x plus 7. And then the graph in red, that's the equation of our secant line. So if we come here to x equals 1, that was the location of our point, x equals 1. And you can see that that line is almost touching that point, which is what in calculus you'll be leading to. Here we're finding the equation of the secant line. In calculus you'll be finding the equation of the tangent line to a point. For this question, we're given the graph of f of x, and we want to answer some questions. So here's the graph of f. And the questions, we want to find the set of all x values that satisfy the inequality f of x is greater than 0, greater than or equal to 0, f of x is less than 0, and f of x is less than or equal to 0. So one thing to note is, what is f of x? F of x is the same thing as y. So when we read these, we're saying y is greater than 0, y is greater than or equal to 0, y is less than 0, y is less than or equal to 0. So we want to make sure that we can get that information from our picture. So we know that the vertical scale that we have, our y-axis, will help us with that. So our y-axis is going to start at 0, which is right here on where it meets the x-axis. So at this point here, the y is 0, that is equal to 0. And then above that, so everything above that, the y is greater than 0. Everything below that point, y is less than 0. So if we're looking for when f of x is greater than 0, we're looking for the pieces of the graph that are above the x-axis. So we have, for this particular picture, one point that is on the x-axis, and all of the other points are above. So we want to represent this piece right here. That piece will go from negative infinity to 3. Now we're writing down the x values, so that's why we use negative infinity all the way up until 3. And then we want to represent the other piece, this piece here, and that piece is going to start at 3 and go to infinity. Now for the next part, part B, it's almost exactly the same question, except for instead of greater than, we have greater than or equal to. So now we don't want just what's above the x-axis, we also want what's on the x-axis, because the y-coordinates are 0 on top of the x-axis. So now we want to include this point that we didn't include previously. So this entire graph is either on or above the x-axis. So that means all of the y values are greater than or equal to 0. So for this one, your answer is going to be all real numbers. For the next one, we're looking for when y is less than 0. So y being less than 0, we're looking for any pieces of the graph that are below the x-axis, and there are none. So for this one, we're going to say does not exist, since there are no pieces of the graph below the x-axis. And the last part is a special case. We have f of x, which is our y, is less than 0. We've just figured out that there are none that are less than 0. But we also have the equal to 0, and we do have one single point that the y is equal to 0. And that's this point here. The ordered pair 3, 0. So this one, we're not able to write interval notation. We're going to write set notation, and we'll write a single point of 3. That is the only x value that satisfies the inequality. Thank you for checking out my videos. Have a great day.